Welcome to the Node Governance podcast, where we discuss all things blockchain, decentralized web, smart contract programming, and cryptography. We're in good company as usual, co-hosting this episode with good old ZK-Lumi, an independent researcher in ZK, also bridging decentralized sequencers and much more, many fields, sir. And we're welcoming today Toghrul Maharramov, who's a senior researcher and elite shitposter at Scroll. It's great to have you on the show. How are you doing?
Good. Thank you. I'm doing good. Thanks for having me.
So I'll start with a question about your routine, Toghrul. What is a day in Toghrul's life? What's the proportion of Twitter posting versus writing papers or doing some research? Could you give us a little breakdown on your routine over the last few weeks? Very curious to know more about that.
Well, it depends a lot on whether I'm traveling or not. Because if I'm traveling, the routine is usually wake up at like 5 a.m. in the morning, go to the airport, be angry at everyone because you woke up at 5 a.m., go and then fly somewhere. Yeah, but usually when I'm at home, also depends. Sometimes I'm just on Twitter all day. Sometimes I work all day. So it depends. You can tell a lot about my productivity by the way I interact with people on Twitter. If I'm like not replying to comments for like 2 days, that means that I'm busy with work or something. If I'm like replying in 2 minutes, that means that I have nothing.
I like the image in my head. I like every time I see you and Anatoly fighting on Twitter, I imagine you guys as a married couple and then him waving you off to work when you're going to travel. And you have some like fights by the dinner, like the wine shit, and he gets
the funny thing is that I actually roughly know when Anatoly wakes up and goes to bed based on the arguments that we have.
Yeah, I think it would be nice to start with a high-level introduction about what Scroll is, and then we'll explore the technical intricacies a little bit later.
Yeah, for sure. So Scroll is a rollup. I know there have been a lot of conversations recently about what a rollup is.
A validity or a ZK rollup?
I hate the word validity. I try to use the word ZK rollup, but I know people from Starkware, especially Eli, might kill me one day for perpetuating the word ZK. So yeah, we are a ZK rollup building on top of Ethereum. Specifically, we're a ZK VM rollup. And if we go even further, we're currently a type 3 ZK VM rollup, but eventually, once a few more things are added, we're going to become type 2 ZK VM rollup. So basically, the way we differ is that we modify Geth currently, but we can also in the future modify Aragon or let's say Nethermind execution client. And basically there are a few minor differences. So the main difference is that we don't use the storage model that Ethereum use. We use a different structure because it's more efficient to proof in circuit. And we feed that execution trace from the existing modified client to our prover, prove it, and that's it. So we don't have to like implement the client from scratch, deal with all that stuff. We just make small modifications to the existing clients, and that's it.
Cool. I remember your talk in ETH Dubai, which was, I think, a response to Calvin Fisher talk called How Rollups Actually Work. And you were going with a presentation that is how rollup actually work. And I think that would be nice for our audience that you succinctly give us the definition of what a rollup is through your
And please tell us if ZKs are real. I'm still having an existential crisis from Kelvin's talk.
I don't know. I had a debate the other day on Twitter Spaces with John and Kelvin, and I'm still confused whether the world that we live in is real or is part of some social consensus. Going back to the talk at ETH Dubai, I think, Sam, you were one of 5 people in the audience that day. So I'm glad that you were there. Otherwise, it would have been you, my brother, and then a couple of more people. Great. Dream audience. So I will define a rollup the way I define it because, as you probably know better than I do, there's no consensus on how to define a rollup of what a rollup even is. But in basic terms, a rollup is just a protocol that publishes the data on some other layer. So, for example, you can use Celestia, Ethereum, etc., etc. Then we go into types of rollups. So there are sovereign rollups and there are classic rollups, or what I refer to as classic rollups, because people just typically refer to them as either rollups or smart contract rollups. And what defines a smart contract rollup or a classic rollup, there are a few things that are required. So a classic rollup has to inherit the data availability guarantees from the underlying layer, which means that the underlying layer guarantees that you can download enough data to reconstruct the state of the rollup. It guarantees the censorship resistance, which basically means that even if a rollup is censoring you, you can always go through the L1 and include a transaction into the rollup. 3, it guarantees validity. So, for example, if, let's say, an execution is made on the L2, and it's proven to the L1 that the execution is being correct, assuming that the proof system is correct, so either a ZK proof system or a fraud proof system, then you are ensured that that execution was correct. And then the 4th one is ordering, which means that, let's say, if I publish a certain sequence of transactions to the L1, and that sequence is finalized, nobody can go later and say, oh, actually, the order of that sequence is completely different, because we basically take the order that L1 defines as the truth, as the canonical truth.
Okay, and to also sort of give transactions fast finality, as well as to get some agreement on how the transactions are ordered before posting to L1, we use sequencers, which are essentially like normal nodes in a blockchain, and they have the two essentially jobs of ordering transactions as well as executing them. And right now, most L2s have centralized sequencers because it's quite hard to decentralize a sequencer network. I would argue it's actually harder than making a blockchain. And so I'm kind of curious, what is Scroll's plans for decentralizing the sequencer network? What kind of consensus mechanisms are you looking for? The short finality, are you planning on doing any executing of transactions on that sequencer network if you declare state? I'm just curious to see where you guys are going with that.
We don't really have anything concrete right now. There are a few options that we're looking into, and the problem is that like every day something new comes up, and it's difficult to commit to something right now, knowing that the space is too immature for us to build something and then be stuck with it for the foreseeable future. So we're exploring a few different paths, but the primary path right now is using some form of a BFT consensus. The leading candidate right now is Hot Stuff 2, which is the new version of Hot Stuff that has optimistic responsiveness, but also only needs 2 phases instead of 3 phases, the way Hot Stuff 1 needed. And basically, the bigger problem for us, because it's relatively trivial to attach the consensus and then call it a day. It's not that difficult. The bigger problem, especially for ZK-rollups, is how do you ensure that the provers and the sequencers are incentivized correctly? So let's say if the sequencers get to keep all the MEV, why would anyone be a prover? Because all the profits go to the sequencer. And we're experimenting, we're looking at a few different things, but I feel like the main candidate right now is some form of enshrined PBS. And PBS stands for Proposer Builder Separation. It basically means that a certain entity gets to build the blocks, construct them, and then the other entity gets to propose them. And that allows us to basically have sequencers bid for the right to have their blocks selected as canonical for that particular slot. And that will result in a fairer distribution of incentives across the 2 roles. And when it comes to parallelization, we are looking into it. There are a few different approaches there. I'm not really sure which one we're going to take, because eventually we're going to have to parallelize. It's just a question of whether we parallelize by modifying EVM or try to make as few changes to EVM as possible. Because one of the concerns that we have, and probably every other ZK EVM builder has, is do we drive the innovation forward and let Ethereum follow that innovation, or do we follow Ethereum? And the problem with the second approach is that Ethereum is sometimes super slow to make changes, and also they're not really incentivized. Parallelization is not really a concern right now for Ethereum. But the problem with driving the innovation is that, let's say, if Ethereum takes a different approach to the same problem, then you're stuck basically with diverging solutions that can never be compatible.
And
Have you guys thought of like forcing access lists for being able to essentially paralyze more easily at least transactions that don't touch the same state? Or I'm curious, like, is that it's just a big problem in that is like it's the incompatibility with certain applications on Ethereum, right?
So there are multiple ways you can do it. You can use strict access lists, so the way Solana does it, where you can only access the slots that you declare. And it's difficult to tell whether that would work on Ethereum, on how many applications would fail to work on it. I'm currently building an archive node, and I'll probably try to go through historic state transitions to try to understand what will be the impact of it. It's difficult to tell, but I'll try to guesstimate. And two, you can use an optional access list. So an access list defines what slots you declare, but then you can also touch other slots, but it will be much more expensive. But that requires modifying EVM, and that's not really great. And the third option is block STM. So similar to how MoveVM does. It's possible to adapt it to EVM, but I'm not sure what would be the efficiency there. We haven't really looked into it, but that's one of the options.
I think Monad is working in some kind of parallelization for the EVM. I don't know much about it, but I'd like to bounce to another question when it comes to rollups. When you go on L2Beat or crypto fees whatsoever, we see that the fees on rollups that are in production, not really rollups, but like L2s, let's call it this way. Yeah, they're not that great because I guess they're bound to publishing data to Ethereum mainnet for most of them. I was curious to know more about the other bottlenecks and the other elements of the rollup stack that have a strong implication on the cost of a transaction. What's the relationship between the sequencer, the prover, and what optimizations we can find on the scroll side to alleviate, to make the situation better for the end user?
So firstly, I'm not quite convinced that the bottleneck currently is DA or it's fully DA. I feel like because a lot of those systems are still immature, and while they are in production, they're still like being constantly optimized, etc. I feel like the execution might still be a bottleneck to some of them, but let's assume that DA is not the bottleneck. The biggest bottleneck for EVM compatible chains is going to be state growth. And depending, I'm not sure how Starkware handles the state, but depending on the way they implement it might also be a problem for them. So we are looking into ways to optimize the state and how we store the state. We haven't really done any changes as of right now because we're concerned with just building the core product and then optimizing it, because it doesn't really make sense to optimize before you actually finish building it. But there are definitely ways we can, I wouldn't say solve it, because I'm not sure if there's like a solution to the problem, but definitely decrease the effects it has on the execution and what you can execute and for how long. And the second bottleneck is what we discussed before, parallelization. Parallelization will definitely become a bottleneck at some point. A lot of people assume that provers are also the bottleneck, but at least for us, it's not really the case, because you can easily parallelize proving. So essentially you can publish 100 batches, assign them to different provers, and have them prove them in parallel. So as long as you have enough provers to prove the parallel batches, it's not really a bottleneck, because it'll roughly grow linearly with the number of provers that you have in the network.
It kind of comes down to the sequencer, which handles ordering and execution. And in the case of a ZK EVM, you're bound to the specs of the EVM, and it's not really
to
common
some degree,
to have.
Yes.
Yeah, parallelized EVM are not really a common thing. So you have to find a way to have parallel execution, whereas ZK VM, because they're built from scratch, they can have parallelization and they are not bound to the constraints of the EVM itself. I was more referring to the cost of transactions and performances too, but that's why I was actually talking about Ethereum, but it makes a lot of sense. So rewriting the sequencer could also be an approach to get better results with a language that's more suitable for production applications.
Yeah, definitely that's one of the options. I feel like there are two things here. One, Geth is not optimized for performance. Geth is optimized for reliability. So you can probably squeeze a lot more performance out of it just by optimizing the implementation. And that's what I like about Solana, is that they are capable of squeezing as much performance as they can out of their implementations. Whereas on Ethereum, in a lot of cases, we care more about reliability, but this reliability comes at a cost of performance. And the second approach is rewriting with optimizations of the protocol in mind, not just optimizing the implementation, but also implementing statelessness, parallelization, some form of state print or state expiry, etc., etc. So there are things that you can do in order to optimize the performance on top of the implementational side. We're still not quite sure whether we want to go with the path of building our own client from scratch, because the problem there is that if we want a multi-client later, we'll have to basically build a multi-client ourselves. And it'll probably make more sense to optimize the existing clients or wait for Wrath to come out and see what's the baseline performance of Wrath, and then see how much more performance we could squeeze out of it by optimizing it even more.
I wonder also in the future, like how much core client teams will start focusing on the L2 vision, because right now they've just been so busy between everything. All of these upgrades have a stupid amount of work behind them, and they seem very tired after the merge. Let's say it that way. And I remember we were at an ETH Magicians meeting, and they were like, people kept pushing new EIPs, new implementations. They're like, can we just take a break for a couple of months? But it will be curious to see how that vision continues to change as the L2 ecosystems actually flourish and become most of the transactions in Ethereum. You know?
Yeah, people definitely underappreciate how much effort it takes to coordinate all the different spec changes, implementations, etc. If it's one team building one client, it's much easier to change things and optimize things because you don't have to wait for the other 4 or 5 teams to do the same. And it's an advantage because it makes the system more resilient, but it's also a disadvantage because all of them depend on one another. And if just one team is like slower by a couple of weeks, the entire upgrade gets screwed and you have to like delay it.
Turns out dictatorships are very efficient.
Yeah,
democracy's hard.
Yep.
This is kind of a question that I think a lot of people seem a little bit confused on, but how much, okay, I don't like TPS. It should be bytes per second. And even then, it's like you said, state is the issue in EVM. It's not how much you allow like transactions to go through, right? So assuming that Scroll doesn't want the state to get too big on L2, like how many factors of scale would you say that Scroll, the one L2 gives to Ethereum? Is it like a factor of a multiple of 1 more Ethereum on Ethereum, or because of the security is an issue, how much would you let the state grow? How much faster would you let it grow?
It depends on a lot of factors. So do you want to keep the nodes for L2 relatively light? If not, you can probably look at BSC and expect the performance to be on par with BSC, probably a bit better than BSC. BSC currently runs Aragon, so it'll be a bit slower, but we can trivially change Aragon to switch to Aragon instead of using Geth. So yeah, I would say you could probably expect no more than even an order of magnitude will be too much. But like, assuming that we are not limiting the hardware, I would say 300, 400 TPS max without any optimizations on the implementation or the protocol side.
And at this moment, I would be curious to know more about the state of Scroll. I think that the testnet has been launched a few months ago. How far are we from mainnet, and what are the main technical challenges that you guys are facing at the moment? I was thinking maybe I'm going to ask about the agenda for decentralizing provers, but I don't know if that makes sense in the current state of affairs on Scroll side.
I mean, we work on a lot of things simultaneously. The team is big enough where we can afford to do multiple things. I mean, when I joined, there was maybe 12, 15 people. Now we have 75. So the team has grown massively, and we're still expanding, and we're still hiring more people. In terms of when, if I was a member of Ethereum Foundation, I would say soon, but in a few months. So I would say, I don't want to commit to exact date, but I would say you will definitely have it by the end of the year if everything is like super problematic, but it should be much earlier than that. There are not a lot of technical challenges left. There are a few that we're still finishing off, but it's mostly audits and adding some features that we're currently missing and testing them on the testnet, because we don't really want to launch the network when it's still not fully tested, and thankfully on an average day we process quite a lot of transactions or our test net, so we have enough of data and enough of testing to ensure that things should go relatively smoothly.
Okay, there's one thing that I always appreciated with Scroll is that this intellectual honesty in the ways you guys communicate around your roadmap, your agenda, and you're not trying to launch your product first whatsoever. And I think that that's definitely something that deserves credit. And yeah, hopefully you can have a stable mainnet launch as soon as possible.
We're trying to be as honest as possible. It's difficult to communicate things in a transparent manner while also explaining people what you're doing exactly, because if you throw in all the terminology and like on the first page on your website, nobody's going to read it and nobody's going to understand but we're doing our best to make sure that people understand the security risks that they're currently taking and they're going to take when the mainnet is going to launch, because not everything is going to be supported from day one and certain things are going to be added later. And I'm making sure that we put enough effort, and it's not only me, so I should clarify, it's a lot of people in our team are making sure that we're putting a lot of effort into the documentation and making sure that people understand what's what and what's actually the security assumptions that they're currently making versus what theoretically they're going to make once all the training wheels and everything come off and everything is fully functioning.
That's always first, I guess this kind of goes back to the conversation with John and Kelvin too. Like that's always the interesting thing of how much can we ever pull off all of the training wheels. And for example, the upgradeability of the validating bridge. Can we ever remove the keys from it to make it just completely non-upgradable and do like a forceful migration like VOV1? What future do you see for that in the long term?
So currently the best that we can do is probably have delayed upgradeability. So let's say Vitalik proposes 30 days. I typically use 28 days. So let's say if you delay upgradeability by 28 days, the users have enough time to exit. Obviously, there are going to be edge cases, but there are edge cases always. Let's say if they're in hard forks once every half a year, let's say someone's funds are locked up for longer. If, let's say, hard fork is malicious, then their funds are stuck on the valuable hard fork again. But that's going back to social consensus, which I don't want to do in this conversation. I feel like there are more things to look into when it comes to how to securely upgrade. And I feel like that's one of the fields within rollups that we haven't really explored that much, not only within Scroll, but within the community as a whole, just because it's assumed that it's far enough that we don't really have to deal with it right now. And yeah, but we're definitely thinking about it internally and having conversations and exploring different options on how to do it. But yeah, there's not a lot that I can say right now, but hopefully in half a year time, we'll have a better understanding.
And lately, I've been hearing a lot about roll-up app chains or L3, so layers built on top of the layer 2, other execution environments, And is there any plans for when it comes to L3s on Scroll side? Are you guys actively researching this? Yeah, what's the fractal scaling roadmap on your end?
Yeah, we're definitely looking into it because firstly, we don't really want to constrain Scroll going forward to a single execution environment and stuff like that. And also for some applications, it just doesn't make sense to share the state with other applications. You might as well just run your own app chain. There's nothing concrete there because we don't really want to focus on it right now. We want to ship the L2 first and then start building out the vision of how we're going to vertically scale later on. We're thinking about it, but it's just conversations internally and visions of how we envision it, etc. But we're definitely going to have something. It's just a question of how it's going to be concretely implemented.
Yeah, it brings us back to that question of how much can you scale Ethereum in any one fractal, essentially, in the L2 or in the L3. And that seems to be the sort of most concrete path moving towards higher and higher scale. Especially if those rollups share the same bridge, then you can just do essentially accounting instead of bridging.
Are you referring to shared sequencers?
Ooh, don't talk dirty to me. Come on. That is the question, though. Just in those internal conversations about how much of that should be centered around like interoperability within those different fractals, you know?
I'll be honest, I'm still not sold on shared sequencers. I feel like for me that the main value proposition of shared sequencers is atomic composability. But the problem with that is that you basically are limited by the finality of the slowest chain and the shared sequence. So let's say if optimism is bridging to scroll and we have the same shared sequencers, scroll finality is essentially equivalent to optimism's finality because you have to wait for those transactions to be finalized. And what's the point of building all the ZK tech if you're going to have the same finality as optimistic rollups? And assuming that all of the L2s are ZK rollups, now instead of having to run just one L2 full node, let's say if I want to interact with scroll directly via scroll full node, now I have to run all the full nodes for every chain that has the shared sequencer, which means that it's going to be almost unviable to the vast majority of the users. So yeah, because one of the things that I value, and I think it's one of the core value propositions of Ethereum, is that you should be able to run a full node. Of course, not everyone will, and I can't expect like my parents to run their own full nodes. But if you want to, you should be able to. And if you do the shared sequencing thing and you have like 10 chains sharing the same sequencer, it's no longer viable.
But if it's just ordering a shared sequencer network rather than like doing lazy execution, essentially, wouldn't you just have to opt into the chains that you care about?
With lazy execution, yes. But for me, the main value proposition of shared sequencer is atomic composability.
Oh, I agree. Yeah.
And for atomic composability, you can't just opt in. You have to run all the nodes, essentially.
From my understanding, you guys are really focusing on getting that L2 ready. So I was thinking of asking you on that previous podcast that we tried to record and that never came out. I think that in one of the papers that you have on some HackMD, Scroll HackMD, proof generation on Scroll is something that's GPU accelerated. And one suggested path to decentralized proof generation would be to have multiple participants with a specific slot assigned, and they would just do their part of the job, and all together they compose the proof. It's a parallelizable process. Fantastic. Are you still assessing like going for that path, or you're going for another approach where multiple provers would compete? And curious to know about that.
I don't want to say we're 100% going for it because things change all the time, but I would say we're convinced that that's the path to go to. The problem with multiple provers competing for a single proof, people like to say that, oh yeah, it's similar to proof of work, but it's not. So one, letting people compete wastes resources, and I feel like it just doesn't make sense in this case. But also proof of work in the context of Bitcoin, there's randomness involved. So your probability of winning is proportional to your hash rate in the system. Whereas with proof, there's no randomness. So whoever is the most efficient always wins, which basically results in centralization at some point. And I just don't feel like it makes sense. If you want a centralized system, just launch a centralized system. It doesn't make sense to launch this permissionless system where people compete, but at the end it results with like two provers actually viably making money because they are the ones that have the most efficient provers. And it also turns into an arms race like in Bitcoin, where people are incentivized to optimize the provers, etc., etc. And so the most skilled prover is going to be the one getting rewarded the most, and it just doesn't make sense for me. And
it was actually sorry, please.
No, I was just saying that. So yeah, we're going to go with the parallelization. We're not going to launch with it because we want to ensure that everything functions as intended when we launch, and we launch with in a relatively controlled environment. But once we ensure that everything is functioning as intended, that's the path that we're planning to go with, the path that you described, Sam.
Yeah, that was a funny story actually from Aleos, which is a ZK-L1 from their test net. They've changed their stack a lot, but they kind of went forwards with that proof of work sort of mentality. And they launched this test net, and turns out the entire test net basically was 51% attacked because one guy came up with a more efficient approver and essentially controlled the entire network for the entire test net. So they had to revert plans on that and actually go back to more of like a random selection process.
Yeah. Like there's no way around it unless you somehow manage to involve randomness. So let's say you actually involve conventional proof of work into proving. It just doesn't work because even if you have 1/1,000,000th of the total network power, but you have the most efficient prover, you're still going to win.
Now, maybe you could just have a system where you have an election of the prover, and based on the amount of token you've staked, maybe your odds to get one of the next slots would increase or something like that.
Yeah, that's the way to go. That's one of the ways to go. You can do it differently. You can just like say, you can just allow people to register and like stake a certain fixed amount and just assign them per proof, or you can do it stake weight. There are a lot of things you can do here, but as long as it's not a competition, you're more than welcome to experiment basically within that.
Okay.
You can also do like through randomness, you can have sort of backup roles. So you assign multiple provers to the same block. And the first one has preferential, so there's no competition. Preferentially gets to submit it, but if he doesn't submit it, he keeps falling back to the other ones and they get some compensation for doing it as well.
Did you manage to have a look at our internal documentation or something?
No,
I'm just joking. But that's what we were thinking of as well. So the idea is that you assign a prover, and then within a certain period, so let's say if within 10 minutes the proof is not submitted, it's either that it falls back to another one, or then you can open it up to anyone. So there are multiple approaches that you can do there, but yeah, that makes sense, because let's say if the prover never appears and you have no fallback, you're essentially stuck. So you have to have a fallback there when you assign prover.
And in regards to, I think that's something that's easily findable in your documentation. And when it comes to developer experience, like all the tooling, the things that we have for Ethereum actually apply for Scroll. We can use all these testing systems like Foundry, Hardhat directly for the code that we want to deploy on Scroll. It is like equivalent in terms of experience.
Almost everything should work. There are a few things that are missing right now, so we don't support a few precompiles. But other than that, and for example, we don't have self-destruct, but we are not planning to add it because Ethereum is planning to remove it, and it just doesn't make sense for us. And a few opcodes function differently. So, for example, runDAO doesn't return the VDF, not the VDF, the runDAO value from the L1, etc. But also, you probably shouldn't use runDAO for randomness, anyways. There are better ways, randomness sources. So yeah, for most of the contracts, you should be able to copy paste the bytecode, deploy it on Scroll, and it should work. But once all the precompiles are added, we should cover 99.9999999%, unless like you use block hash and expect to prove the inclusion of a certain receipt within that block hash, then that won't work, for example. But other than that, almost everything.
Okay, and could you tell me more about what the community first slogan means when it comes to Scroll's communication?
Scroll started as a collaboration project with Ethereum Foundation's BSC, essentially. So it's in our DNA to collaborate with people and to have people contribute to our code, etc., etc. And therefore, there are obviously certain things that are currently closed source, but most of the things that are relevant are open source. So one thing that is currently closed source, but it's going to be open source soon, is the bridge. But the reason why we haven't open sourced it is because in the last few months, we changed it quite drastically. And it just doesn't make sense for us to open source the version that we know has certain things that are not optimal, because we know that people might fork it and build their own project on it, and it just doesn't make sense. So the bridge will be open source soon. It's currently undergoing an audit. So once the audit is done, we're going to open source it. And it's just about our internal values, about collaborating with people, making sure that the community is involved, is their opinions are heard, etc., etc. Because for us, it doesn't really, we don't really want to be on a high horse when we look down on everyone else and say, oh yeah, we are the ones who know what to do, and we don't really care about your opinion, because that's not the way you improve protocols and make sure that your stuff doesn't stagnate. So we are always open to external opinions or external suggestions or external contributions in any way, shape, or form.
Airdrop hunters, you've been heard. Just note it.
No comment there.
I'm not touching that one. So your research at Scroll, and like you have kind of open reign to research things that, well, hopefully they're relevant, but to research things that are exciting and might help Scroll in the future.
I only research irrelevant things now.
Yeah, what are kind of things that you're looking at right now? Is it folding schemes, or that you find sort of like very exciting right now for the future of blockchain as a whole, or how to piss off Anatoly, or whatever topics that you're interested in right now?
There are so many different things that it's probably going to take me an hour to outline everything that I'm excited about. But yeah, folding schemes, again, not my strength, but yeah, folding schemes is one of the things that we're looking into. And whoever has been to Zuzalo or heard about Zuzalo knows that like 30% of the time there was spent by people talking about folding schemes. And there are so many things. So execution environments, optimizations. Another thing that we're also interested in is how to optimize the bridging experience between, let's say, if you have multiple chains that are built on top of you, how to make sure that the composability is seamless, etc., etc. Another thing that a few people highlighted recently, and I think it's going to come into play more and more in the coming months/year, is the security of the bridge. So, for example, multi-provers, multi-verifiers. I'm not going to shill my own proposals here. But so, for example, I'm not sure if you guys read, but there's an article on ETH Research by Justin Drake who proposes using SGX as two-factor authentication for zero-knowledge rollups. And I feel like that's one of the few use cases for SGX that actually shouldn't be concerning, because it's essentially additive. So let's say if SGX fails, the worst that can happen is basically you don't have two-factor authentication. And so you don't lose any security as long as the zero-knowledge part works as intended. And yeah, stuff like that. And I feel like right now, not a lot of people talk about it, but roll-up contracts are not trivial, and they're quite complex beasts that need a lot of care to make sure that they function correctly. And like, I'm not sure if you've followed, but Lido for their V2 implementation did 9 audits, and every audit managed to find a different bug. And so it's almost impossible to ensure that your code is absolutely correct and has no errors. And so you need to make sure that you somehow have precautions, and not precautions in a sense that you have a centralized committee that basically stops every time something goes wrong, but actually security precautions baked into the smart contracts to make sure that in case something goes wrong, your bridge doesn't get drained, but a certain thing happens that like either pauses it or falls back to something else or whatever.
Plus those code bases are like hundreds of thousands of lines of code. They're not simple programs. So
thankfully, bridges are not that complex. They're probably less than hundreds of thousands of lines, but still. But like if you combine the circuits, everything, yeah, it's probably tens of thousands, if not like 100,000 lines of code.
Yeah, and it's hard, especially like in this. It's a fairly new field, especially zero-knowledge circuits, but also L2s, where you have a fairly limited amount of people that can even audit them or can look through them. I still like this. I was sitting with a friend from Polygon. This is Layer 2 Day in Remember in Amsterdam. And Jordi was on the stage, and they asked him, like, who's going to audit your prover? And he's like, on stage, he's like, well, it's kind of difficult. And my friend turns over to me like, Jordi audits his own proofs. It's nice that you guys are putting so much critical effort into security, because I think there's going to be definitely a lot of bugs that we find in the future, and hopefully that doesn't put customer assets at risk at any point.
Even our internal team has found 3 bugs in 3 different rollups already. Like we found a bug in Aztec, we found a bug in Polygon, and we also found a bug somewhere else. I don't remember, but yeah, I think it was 3 bugs in total in different. And it's not me saying that we are going to be secure, whereas they're completely insecure. We're all in the same boat here, so somebody might find bugs in our implementation as well. But like,
I think it's a nice idea, actually. Like, it's not the perfect way to audit, but it would be interesting getting like all the L2s to take a month off and just stare at each other's protocols.
But I feel like
what comes out.
But I feel like that's gonna already happening. It's gonna happen anyways because we study what the other people implemented, and the more fresh eyes you get on the same problem, the more problems can be discovered that way. So that's how the bugs that we discovered have been discovered. We just have been studying their code base and stumbled upon something that was wrong, and then we just got in touch with them and said, "Oh, guys, by the way, that's broken."
It's a very casual. Oh, you're about to lose all the money, but don't worry. Take a look at it.
I don't think the bugs were that bad. But
yeah.
I think that it must be a very stressful position to actually be leading efforts on a ZK or validity rollup, because I think there's some kind of Cold War, maybe some research companies or your competitors actually have vulnerabilities that they haven't disclosed, and they're waiting for the TVL, like ATH, to actually pull the rug and get you wrecked. And it's funny because there are also some companies that contribute to multiple ZK protocols and probably work under NDAs, but they work actually with multiple companies and have access to the code bases in their deepest aspects, let's put it this way. So I think that we'll need quite some time until we can consider ZK rollups safe. And that's also one key factor, I believe, for liquidity to actually arrive on these systems. So it's definitely interesting, but we're at the frontier of something big. But yeah, you never know what can happen. My take is that there's some kind of SecOps going on.
It might be, but that's why I always joke internally that we can still enjoy our lives, because once the mainnet is launched and you have money locked in there, the life becomes completely different. Every single morning you wake up, you see Telegram messages, you're like, oh fuck, did something happen?
Yeah.
Is it Samsung messaging that he discovered something?
Security is always a function of time x like money, and luckily at least we'll find out relatively quickly in blockchain, because there's a lot of money if there's secure or not.
Yeah, but it's the blockchain is blockchains are an amazing bug bounty, because if you fuck around, you'll find out quite quickly that you fucked around.
You can think maybe of adding some kind of optimistic system on top of your rollup bridge, and depending on the amount that's being transferred, you can have some watchers that can challenge the actual transfer to prevent the money from being some kind of circuit breaker.
There are multiple things you can do, definitely. Yeah, 100%. And we are exploring a couple of paths there. So yeah, I feel like you need to take some precautions, otherwise it's just impossible to ensure that it's going to be 100% secure. While I would love to believe that there are no bugs, it's genuinely like impossible to guarantee that that's true.
That's always been true in Web 2 as well. Like, you're trusting your bank is not going to be hacked, or databases deleted, or that everything on the internet starts blowing up overnight. Like these are the always like security assumptions. That's something I like about crypto, though, is at least people are upfront about it and talk about it, rather than being like, no, it's good, like real good, this best product.
The only disadvantage here is that because everything is permissionless and completely transparent, with the bank you can always stop it by having internal precautions. Here there are no precautions. If the app is broken, it's broken, that's it. Especially if it's immutable,
or assuming you don't have the SPF running it.
Yeah, true, but I don't really want to go there. I heard enough of his name last year to.
Another thing that I believe that you're using snarks on Scroll for your proof, like your prover generates snarks, and that's the kind of proofs that you use and verify on mainnet. And these proofs are known not to be quantum resistant. So maybe in 10 years or 7 years, we'll have some machines that are able to compromise the security of these schemes. Do you have an agenda, or do you eventually consider moving to Starks in the future?
I feel like if quantum computers are capable of breaking the cryptographic assumptions, we have bigger problems. We have bigger problems than provers being broken. And also bear in mind, even if it would be theoretically possible, it would still take quite a long time to break it. It's not like a quantum computer all of a sudden can break a proof in a minute. It's still going to take like 3-4 years of computation to prove it. It just becomes viable within like our lifespan, let's say. But it's such a long way away that it just doesn't really make sense for us to consider right now. And also bear in mind that Ethereum signature schemes are not quantum safe. A lot of things that our protocol is based on are not quantum safe. So let's say even if you make the proof quantum safe, the protocol is still not secure, because let's say we still use ECDSA. So if the elliptic curve behind it gets broken, that's it. You can still have your money still then. So there are a lot of things that need to change before we actually do something about it. And thankfully, with account abstraction and stuff like that, it will be much easier to change things without like rewriting the entire protocol from scratch. Yeah.
Well, at least when it comes to signature, and that's in the case of, we spoke about the case of rollups here, but that's also a problem for Bitcoin, and surely there's enough time to actually address it. And I would be a bit more concerned about, definitely nuclear plants or
and before other communities use that as an opportunity to start jumping on Ethereum, there are plans to change the signature scheme and make the protocol quantum resistant. So at least it'd be possible at some point. That is interesting though. Like, how would you have to redo everything, or how easy is it just to switch a Stark in, or could you make a Stark of Snarks? Or like, I am kind of curious of like, if we find out tomorrow, turns out China made a massive quantum computer, they're 50 years before than we thought they were, and this happened, like, let's go, we have to fix these protocols. How quick or easy would that be?
I don't think Scroll is going to be their main target. There are bigger targets for China to first hack before they move their attention to Scroll. So I feel like we will still have enough time to fix.
But I'm curious, like how much of an involved process is that?
Again, I'm probably not the right person to ask it, because it always happens internally, like something to do with cryptography. I'm like, oh yeah, it's fine. It's going to take you guys like 2 weeks. And then they're like, what the hell are you talking about? It's like a 6-month refactor here. No. I'm like, I'm glad I'm not part of the cryptography. We wouldn't have been able to achieve anything then.
Oh, man.
Yeah. I guess that wraps up that episode. As usual, I'll leave all the relevant links in the description if you want to connect with Daniel or Toghrul. And if you have any questions, feel free to ask them in the comment section. I think that was a very fun one. I hope to welcome you again on the show, Toghrul. And I'll see you soon, guys.
Thanks for having me. See you guys.